RMI architecture in Java remote method invocation. Here you can see Java RMI architecture in a different view. Java RMI is designed to simplify the communication between two objects in a different virtual machines by allowing an object to object in an object to invoke the methods of an object in another virtual machine in the same way as methods on local objects invoke. To invoke methods on a remote object, remote reference to that object has to be obtained, since the object resides in the different virtual machine and hence in a different namespace. The registry is used to manage remote references. RMI servers can register their objects in a registry, after which clients can obtain a reference to those remote objects. The general architecture of RMI is shown in this figure. The first server creates a remote object and registered it at the registry, which is shown by arrows 1 here in the figure. The client can obtain references to object stored in the registry, as shown in the arrow true here, in the arrows here. When the client invokes a method on a remote object, the method is actually invoked, shown by arrow 3 here, on a stub object located in the same JVM as the client's JVM. The stub object makes a message containing a name of the method together with the parameters called marshalling, and send this message, shown by arrow 4, to the associated skeleton object residing in the server's JVM. The skeleton object extracts the method name and parameters from the message called unmarshalling, and invokes the appropriate method on the remote object with which it is associated, shown by arrow 5 here. Remote objects executes the method and passes the return value back to the skeleton, arrow 6 here. The skeleton in turn marshals the return value in the message and sends this message to stub object, arrow 7. The stub unmarshals the return value from the message and returns this value to the client program, arrow 8. The methods of a remote object can be invoked remotely must be specified an interface that extend the RMI defined remote interface. Every method in the interface must be declared to throw the remote exception in order to account for errors during remote method invocation. A number of subclasses of remote exception are defined that represent the various errors that can occur. A remote object typically declared to implement at least one remote interface and also extend the remote server class or one of its subclasses. After creating a remote object, it needs to be exported, which makes it available for remote access. Once created and exported, the remote object must be registered with the registry by invoking either bind or rebind method of the naming class, providing them with the remote object and an appropriate name. The remote interface of the remote object is used as the type of the remote reference on the client side, A remote reference can be obtained by invoking lookup method of the naming class, providing the name of the desired remote object. When invoking a method through the remote interface, remote exception must be caused to handle the errors during the remote method invocation. Exceptions that occur during the actual execution of the remote method at the server are known to the client. Server are thrown to the client encapsulated in a server runtime exception object. Other exceptions occurring at the server are encapsulated in a server exception object. After writing and compiling a remote interface and the remote object implementation, the RMI stub skeleton compiler RMIC can be used to generate stub and skeleton pair for accessing the remote object. The stub and skeleton, and thus the entire communication is completely shielded from the programmer. Here you can see a client host and here server host. Client object and stubs are inside the client host. Registry, server, remote object and skeleton are inside the server host. Here step 1, registry interact with remote object and server interact with register and remote object here. Here registry interacts with the client object, and here 3 client object is connected to stub. 4 stub is connected to skeleton. Skeleton is connected to remote object. A remote object is connected to skeleton. Skeleton is connected to stub. Stub is connected to client object. Now this is the end of my presentation. Thank you very much for watching it.